This lesson is on 7.5, which is percent of change. So there's a few vocabulary words we should go over with. Basically, we're finding the percent of a change, and this could be in value, of price. For example, if something's 50% off, that means there's a 50% decrease from the original amount. So we're going to talk about two vocabulary words. So a percent of change in general indicates how much a quantity increases or decreases with respect to its original amount. So you just have to keep in mind what was its original amount to figure out how it changed. So we have a percent of increase is the percent of change in a quantity when the new amount of the quantity is greater than the original amount. Or a percent of decrease, the percent of the change in a quantity when the new amount of the quantity is less than the original amount. So basically, if the new amount is less than the original, it decreased. If the new amount is greater than the original, it increased. And the equation we're going to use, the percent of change is the ratio of the amount of increase or decrease to the original amount. So the amount of increase or decrease is going to be the difference between them. So we have subtraction going on the top divided by the original amount. So let's try it out. So a school has 720 students enrolled last year. This year we have 745 students enrolled. About what percent did the number of students change from last year to this year? So in this case, we can see it increased, and it increased by 25 students, because 745 minus 20 leaves us with 25, divided by how many were last year, so the original amount, which is 720. So 25 divided by 720 is 0.035, but it's a percent we want it in, so we need to multiply by 100 to get 3.5%. So the number of students increased by about 3.5%. Let's try a problem where now we have a decrease. So find the percent of decrease from 576 to 216. So from is indicating where it started. So this is going to be our original amount. This is our new amount. Sometimes it helps me to actually label them in the problem, so I set it up right. So in this case, we'd have 576 minus 216 divided by the 576, which leaves us with 360 divided by 576, which is equivalent to 5/8, which equals 62.5%. But we have to be careful here. We're not done because we just used the amount of the increase, which actually this should say decrease, right? We need to make sure we label it as such. So the percent decrease is 62.5%. Make sure you label it as a decrease. So what I want you to do is try two problems. One where you're finding the percent of decrease, and the other when you're finding the percent of increase. So press pause and give those a try. So example 3 is using a percent of increase. So in this problem, let's do a word problem. So in 1999, the total attendance at the U.S. Symphony Orchestras was 30,800,000. Attendance increased by about 2.9% between 1999 to 2000. What was the approximate attendance in the year 2000? So in this case, we want to find out how many people attended in 2000. They gave us this percent increase. So we have 2,000 attended in 2000, the year 2000 attendance is going to equal the 1999 attendance plus the amount of increase. So in this case, let's write down how many people attended in 1999 plus 2.9% times that amount. that attended in 1999. This is going to give us our increase. We need to go back and make sure we write that percent as a decimal before multiplying, which then, after we multiply it and add it together, we can approximate the 2000 attendance at 31,693,200 people attended the next year. Another way of doing this, if you prefer, is we take this number, 30,800, and sorry, this is going to be a little sloppy. I don't have a good mouse right now. It's the same thing as multiplying 1 times that plus the decimal here, which is 0.029. So we can add this together first to get 1.029 and multiply that by this 30,800,000. So I'll leave it up to you. This ends up being easier because we just use our knowledge of the distributive property. Either way, you'll still get the same answer. So finding a new amount. So your 5K time for the race of the cross-country season was 25 minutes. So that's the very first race. So your original time. Your time for the last race of the season decreased by 12%. So that means you ran it faster. That's good. You improved throughout the season. What was your last race time of the season? So in this case, we have our last race time equals our first race time times 100% minus the percent it decreased by. So I'm setting it up like I showed you on the last page in this case. So 25 minutes times 100% minus 12% gives us 25 times 88%. Then rewrite that 88% as 0.88, multiply in 22. So we can conclude that it took you only 22 minutes to run the last 5K of the season. So I want you to give this a try. So I want you to try these two problems below. Increase 60 by 85% and then decrease 80 by 0.5%. So go ahead and try them, keeping in mind when you decrease, you're going to have subtraction. When you increase, you're going to have addition. And we'll go over these problems tomorrow in class. That's all for this lesson.